Hello students, this is the third problem under the topic hyperbolic functions. Now here it is given that u is equal to log of tan pi by 4 plus theta by 2. We have to prove that tan h u by 2 is equal to tan theta by 2. So now here first whatever is given that we will write here. So what is given? It is given that u is equal to log of tan pi by 4 plus theta by 2. Now in this we will have the base of the log to be e. That is, we can apply a formula here which says that suppose if we have log a to the base e to be equal to b, then we can write that a is equal to e raised to the power b. So this is a formula in the logarithm. So now we can apply this formula over here. Now here at the, for example, we have this, so this can be rewritten as u, that is we can write this as log to the base e tan pi by 4 plus theta by 2 is equal to u. So now it is in this form. So now if you notice here at the place of a we are having tan pi by 4 plus theta by 2, and at the place b we are having u. So this can be transformed as a is equal to e to the power b. So now what is a? As I told you, this is a. So that is tan of pi by 4 plus theta by 2 will be equal to e raised to the power of u. So e raised to the power of u. So this is what we obtained by this. So after this we can expand tan pi by 4 plus theta by 2 by using the formula tan a plus b. So what is that formula? So we have tan a plus b to be equal to tan a plus tan b the whole divided by 1 negative tan a tan b. So now we shall expand this left hand side by using this formula. So while using this formula here, now this can be written as, now what we will do, we will have this e to the power of u to the left. So that is equal to, so now this has to be expanded by using tan a plus b. Now at the place of a, what are we having? Pi by 4. At the place of b, we are having theta by 2. So it will be tan a. So a is what? Pi by 4. So tan pi by 4 plus tan b. What is b? Theta by 2. The whole divided by 1 negative tan a. So tan pi by 4 and then tan b. So tan b is what? Theta by 2. But as per the trigonometric formula, we also know that tan pi by 4 is equal to 1. So actually what is tan pi by 4? It is the angle 45 degrees. So tan 45 is equal to 1. So we can apply this over here. And so what we will be getting is e to the power u to be equal to tan pi by 4 is 1. So 1 plus tan theta by 2. The whole divided by 1 negative. Now here tan pi by 4 is 1. So 1 multiplied by tan theta by 2, and so it will be tan theta by 2. And so let us mark this as some equation 1. So that we will be using this e power u in future, where we can refer this as equation 1. So let us proceed further. So now next, as per the question, we have to prove this. That is, we have to prove that tan h u by 2 is equal to tan theta by 2. So let us take that and write. So we have to prove tan h by u by 2 is equal to tan theta by 2. So let us consider the left hand side. So what is the left hand side of this? The left hand side is tan h u by 2. Now this can be written as sin h u by 2 divided by cos h u by 2, because we know that tan h u by 2 is equal to sin h by cos h. So that is what we have written. But as per the hyperbolic formula, what is sin hx and cos hx? Let us see that now. So already I have given the formula list where I have given sin hx and cos hx. So sin hx is e power x negative e power negative x by 2. Now here at the place of x we are having u by 2. So we have to, wherever we have x here, x in this formula, we have to replace it by u by 2. Similarly, here we have cos h u by 2. So in this formula, at the place of x, we have to replace it by u by 2. And so here we have to replace by u by 2 and here also. And then we have to proceed further. Let us see that now. So if you see, I have taken both the formulas and I have written here. Now here at the place of x, we have to replace it by u by 2. And in this formula also, we have to replace this x by u by 2. And after replacement, what do we get? We will see next. So after substitution, this we get. That is sin h u by 2 will be this whole thing. So at the place of x I have substituted u by 2 and cos h u by 2 will be this whole thing. Now this is the denominator of the numerator and this is the denominator of the denominator, and so these two will get cancelled, and so finally we will be left out with after these we cancel these two, we can write this, that is it will become e to the power of u by 2 negative e to the power of negative u by 2 the whole divided by e to the power of u by 2 plus e to the power of negative u by 2. We shall simplify this further. So now in order to simplify it further, this can be written as e to the power of u by 2, we will write it as such, negative this e to the power of negative u by 2, we can write it as 1 by e to the power of u by 2, because this negative it has a negative power, and when this is taken to the denominator the power becomes positive. So e power negative u by 2 will be equal to 1 by e to the power of u by 2, the whole divided by, in the denominator, e to the power of u by 2 plus, now this term will also be like 1 by e to the power of u by 2. We have a negative power, and so when we take it to the when we write it like 1 by e to the power of u, it will become positive e to the power of u by 2. So after this we will take the LCM. So in the numerator the LCM is e to the power of u by 2, and this will get multiplied, and so what we will get? So we will get e to the power of u by 2 multiplied with e to the power of u by 2, so that is the whole squared, negative 1, the whole divided by, now this and this we have to take the LCM here, it is e to the power of u by 2, so this and this will get multiplied and it will become e to the power of u by 2 the whole squared plus 1. So that will be equal to, further we will simplify it. Now what is this actually? This 2 and this 2 will get cancelled, and so you will have e to the power of u negative 1 divided by e to the power of u by 2 multiplied with, this can be written like this, e to the power of u by 2 divided by this term. So now here also this 2 and this 2 will get cancelled, and so we will have e to the power of u plus 1. And so now this and this will get cancelled, and finally here we will be having e to the power of u negative 1 divided by e to the power of u plus 1. So now what we will do, already we have evaluated e to the power of u in equation 1. So if you see the previous steps you will get to know it. So that e to the power of u we will substitute here. That is, we are having it here. So if you see here, we have already evaluated e to the power of u and we have marked it as equation 1. So this e to the power of u value, now I am going to substitute over there. So what will happen, at the place of e power u, we will have 1 plus tan theta by 2 divided by 1 negative tan theta by 2. So let us do that substitution and let's see what happens next. So after substituting, at the place of e power u, 1 plus tan theta by 2 divided by 1 negative tan theta by 2, we obtain this. So here we have e power u and here also we have e power u. So from equation 1, we have applied it here. Now next we will take the LCM in the numerator, and here the LCM is 1 negative tan theta by 2. And so here in the numerator we will have 1 plus tan theta by 2 negative, so this gets multiplied with this one, so 1 negative tan theta by 2. And in the denominator also we will take the LCM, and so the LCM will be 1 negative tan theta by 2, and here we will have 1 plus tan theta by 2 plus, so this gets multiplied with 1, and so we will have 1 negative tan theta by 2. And now we will simplify this further, and so that will be equal to, so when we simplify in the numerator here we will have 1 plus tan theta by 2. Now this negative sign gets multiplied within the bracket, so negative multiplied with 1 will be negative 1, and then negative 1, negative and negative gets multiplied, and so it will become positive tan theta by 2, the whole divided by 1 negative tan theta by 2. Now multiplied with this we can take it to the numerator, so it will be 1 negative tan theta by 2, the whole divided by, this will come here in the denominator, because when we get into multiplication it will become the reciprocal here, so it will change, and we will be getting 1 plus tan theta by 2 and then plus 1 negative tan theta by 2. And so now if you see further on simplification, this will be equal to, now if you see here we have a plus 1 and a negative 1, so these two will get cancelled, and we will get tan theta by 2 plus tan theta by 2, which is 2 tan theta by 2. We can add both, and then if you see 1 negative tan theta by 2, and these two terms gets cancelled with each other. And now here whatever is left out we will see, so here we have plus tan theta by 2 and negative tan theta by 2, and so these two terms will get cancelled, and we have 1 plus 1, and so divided by 2 alone we will have, and further this 2 and this 2 will get cancelled, and finally we are getting tan theta by 2. So this is our right hand side. So we have proved. So this is what we are required to prove. So if we get back to the problem, we can question, we can see that. So we have to prove that tan hu by 2 is equal to tan theta by 2. So we started here with tan hu by 2. We made few substitutions by using the formulas, and then we simplified it more, and finally we have got tan h. So if you see, this was where we started. So tan hu by 2. So tan hu by 2, we have got this. So therefore, we have proved that tan hu by 2 is equal to tan theta by 2. Hope you have understood this proof. This problem is also an important problem in the examination point of view. Hope you have understood the complete solution to this problem. So hence we have proved it. Thank you.